Okay, class, today we are going to work on the same stuff we've been working on in the last couple sections, only we're going to do it with three sets. In the last section, we were doing set operations on two sets, like A intersected with B, or A union with B, or C complement. Today we're going to allow a third set to come into the picture. So I'm going to bring up a chart here from the book. Okay, you can see this is just a good summary of what all these terms mean. Only they introduce a third set here, like in this situation. This is the A union B. Letter B is A union B, set of elements in A or B or both. That's a way to think about it. So that's the metaphor I gave of my wife and I. She has her possessions in her house A, I have my possessions in my house B. We come together into one house, and what's all the possessions we now have? We're unioning up those possessions. We're combining them, I guess you could think of it. And then we've got B intersected with C, the set of elements in both B and C. So that's the part they have in common. If we do the Venn diagram, that's the part where the circles intersect. C complement, that's everything outside of C that's in my universe. Again, we always define a universal set in any of the problems. And then A intersect B intersect C. That's all the things in A, B, and C. So a picture I could draw of that one is now I'm going to have three sets intersecting. Potentially, maybe like this. Okay, where I have A, B, and C. This is a Venn diagram. This little region right here is the region where all three of them intersect. Okay, so that little region right there would be A intersected with B intersected with C. Okay, so that's how we're gonna start addressing problems like that in this section. All right, so let's start messing around with this, and we'll go from there. Okay, class, here's an example where I've got a universe square, and I've got a Venn diagram with an A, B, and a C circle, and we're going to mess around with doing some set operations using the Venn diagram. So let's first start off with something simple. Okay, so what is A equal to? Well, what's in the set A? Well, that's actually pretty easy. We would just list everything in the A circle. Looks like it's A, B, and C, L and M, 11, 4, and 7. All I did was do this. Whoops, my bad, not that. All those ones right there are in the A circle, okay? Let's do some harder ones now. Let's do A unioned with B complement. Okay, so first what we're going to do is let's find A unioned with B. So that's everything in A and B. Well, that would be A, B, C, L, M, 11, 4, 7, right? And then everything additional that's in B, Z, X, and Y. Okay, that's all the things in A union B. Because remember, A union B is just take everything in the A circle or the B circle. Now we're going to take the complement of that set, so everything outside of that list. Well, what's everything outside A or B? Well, that would be 56, which is chilling out here, right? And 29. So 56 and 29 are going to be in there. What else is going to be in there? It looks like just 19, right? Okay, so that would be A unioned with B complement. All right, let me erase a little bit. So we'll do a couple more. We'll do some with three sets. Okay, let's look at Let's look at A intersected with B complement unioned with C. So here's what you do. Here's how I do this problem is I first find, let's actually write this out in set notation. So let's put the parentheses right here, and let's write A down, which we already have done. A, B, C, L, M, 11, 4, 7. Order doesn't matter. We're going to union that. We're out of room. That's okay. We can wrap with B complement. Okay? That's everything outside of B that's in the universe. So basically, we're just going to cross out the whole B circle and take all the other things outside of it. Okay? And so all the things outside of B are A, B, and C. L and M are outside of B as well. 19 is outside of B. 56 and 29 are outside of B, because they're out in the universe outside both of them. So I'm going to union those first, and then I'm going to union that whole thing in parentheses with C, which is L, M, 11, Z, and 19 are all the things in C. So if I take a look at the first part, if I union all that up, put all those together, what's going to be in those first two sets in parentheses? So I'm going to union this and this first, because remember, in order of operations, you do what's in parentheses first. That's the same for sets. We're going to union those up first. So in those, I get A, whoops, let's get that in black. I get A, B, C, L, M, 11, 4, 7, 19, 56, and 29. And then I'm going to union that with this. I'm not going to recopy it. Okay. And when I do that, the L, the M, the 11, the Z, and the 19, the only thing that's new in this set that's not in the other set is the Z, correct? All the other ones are repeats, L, M, 11, and 19. So all I'm going to do is really add Z. So I'm out of room down here. That's okay. So my final answer is going to be this whole set with a Z added. So I'll write the answer up here. A, B, C, L, M, 11, 4, 7, 19, 56, 29, Z. That's my final answer when I do that. So notice what I did, guys, is I first found B complement, and I wrote that. Then my next step was that I unioned A with the B complement. Then once I'm done with that, because that's in parentheses, I unioned it with the C. Okay, so that is a good example problem on how to mess with that. Now let's take another one. I can use the same set. And I could do A intersected with B. Okay. Complement intersected with C. Okay, so let's do A intersected with B first. Let's do what's inside here. That's going to be A intersected with B is the things in both A and B. So that'd be these, right? Those are the two things that are in the A and B circle. So that'd be 4, 7, and 11. I'm going to take the complement of that, and I'm going to intersect it with C, which is LM. Hang on, let me erase this little thing in the way I didn't quite get. That's LM 11Z19. So those are the things in C. So 4, 7, 11 complement, well, that's everything outside 4, 7, and 11. So I'm basically going to cross out 4, 7, and 11 and take everything besides those three elements that are in the universe. So that's a huge list. That's okay. Sometimes you just have to be tedious with this and write it all down. That'd be A, B, C, L, M, X, Y, and Z, 1956, 29, intersected with L, M, 11, Z, 19. Okay, now what do they have in common? It looks like they have in common L, M, Z, and 19. Those are the four things they have in common, correct? So this would equal, because we're doing intersection, by the way, we're looking at what they have in common now. So that would be L, M, Z, and 19. That'll be my final answer for that. Okay, now let's mess around with a Venn diagram, and let's talk about which of the regions represents A intersect B. Okay, so that would be obviously region 2, correct? Okay, which regions represent B unioned with A? Okay, B unioned with A. Well, wouldn't that be 1, 2, and 3? All of them are in either B or A. That's when we're unioning up all the things. And then what would be B union A complement? Well, that would be everything outside of B union A, right? Everything outside, complement means outside, but in the universe, B union A. So this is B union A, so everything outside of that would just be what? Region 4. Okay, hopefully you're kind of getting a picture of how this works. Okay, let's try one with 3 now that's similar to this problem. So now we're going to do a similar problem where we try to figure out what regions are representing a given set of set algebra. We're going to do some set algebra here and figure out what regions represent it. So let's try this one. Let's go with A union B intersected with C. Okay, so let's write this out for a second. That would be, we can just do some side work here. A union B would be regions 1, 2, 3, 4, 5, and 6. Okay, we're going to intersect that with the region C, which is region 4, 5, 6, and 7. Okay, that's C. So A union B is the combination of A and B, or things that are in A or B, so that'd be all those regions. And then C is 4, 5, 6, and 7. So what's the intersection? Well, it's pretty clear. They intersect at region 4, and at region 5, and at region 6. Okay, so this equals regions 4, 5, and 6 are the 3 regions. Okay? Let's erase that. Let's try another one. Okay, so let's try A intersected with C, unioned with B intersected with C. Okay, so sometimes you can do these by kind of shading. So let's look at A intersected with C. Well, A intersected with C would be this little region right there. Right? It'd be that little region. That'd be A and C. That's what they have in common. B and C, in blue, would be this little region in common. Right? So what do they both have in common? What they both have in common is this region right here, which is region, you can't see it very well, but is region 5. So region 5. Okay, that's an example with 3. At this point, I'm going to give the Easter egg for this video. You should write this number down. This is for section 2.4, 900765. That's 900765. Okay, now going back to the example we're going to do, what if I asked you, if I gave you an equality here like this, B intersected with A union C, and I asked you to tell me if that equals A intersect B unioned with B intersect C. So I'm asking you to tell me, are these two equal? Okay, and a way you can do this is you can draw a Venn diagram for each side and see if they work. So let's draw a Venn diagram for the first side. We will draw this one in red. Okay, so let's draw three circles interacting as we have been, like this. And let's try to shade the parts that fit this. Having colored pencils is actually kind of helpful here. So let's first do the thing in parentheses, which is this A union C part. So I should probably label these. This is A, B, and C. So if I want to do A union C, that'd be all the things in A or C. So you basically merge up those two like that. Okay, that's A union C. I want to now intersect that with B. So I want to find what that shaded region I just did has in common with B. Well, wouldn't that be this part right here? That's the part. That should be the part the shaded region has in common with B. That's where B intersects that shaded region we just created. Okay, so let's try the right side. We'll do this one in black. So we'll do our 3 circles again. And we'll call this A, we'll call this B, we'll call this C, and see if we get the same shaded region as our solution. So if I do A intersected with B, I'll shade that in red. That's everything that A and B have in common, right? Right there. And then I'm going to do, so I did A intersect B. I'm going to do B intersected with C, because that's in parentheses as well. I'll do that in blue. That's everything that B and C have in common, right? And then I'm going to union those two up. Well, that would be just literally shade that whole thing. Union them up means we just shade both regions. It looks like that's the same exact region that I got on the left. Do you guys see that? These two regions are the same. So this is a true equality. Okay, so you might get some example problems like that you'll have to do in your homework. So that pretty much covers all the different types of problems you may run into. We have our Zoom meeting later today. That's a reminder. We'll get together. I'm mainly going to be answering questions during that. And if there's not a lot of questions, we will move on. We'll do some introductions too. So hope that all helps, and we'll see you soon.